So this is a study material, and it just is some exercises to work with the cardiac cycle. The answer key to this, one of the few times I post an answer key, the only time, is on D2L. Okay, so when you go to the lab section of D2L, it'll have an answer key to page 36 through 38. So if you want to start, if you want to work on that, and that has to do with what we're going to cover next. So when we were talking back to heart anatomy, and we were talking about the atria, blood flows into the atria at the same time. The AV valves are open. Blood flows continuing through the atria, through the AV valves, into the ventricles. Then both atria contract, and then both ventricles contract, and then the heart relaxes. That's one cardiac cycle. So we have ventricular filling, while the blood is flowing through the atria, both of them open into the ventricles. Atrial contraction, both atria contract at the same time, and while they're relaxing, both ventricles contract, and then the atria and ventricles are both relaxed. So we showed that kind of in our ECG. Right? So that's the events of the cardiac cycle. So what you're looking at in this diagram, we're looking at an anterior view of the heart. So you see the atria contract, and then ventricles contract. So as the AV valves close, we have a lub duct that you're hearing with the stethoscope that has to do with the valves. So when we talk about cardiac cycle, we're going to look at the events. Well, this is kind of taking it through step by step. So the heart is in ventricular filling. That's the rest period. That's that period between the T wave and the P wave. Okay, a little bit past the P wave, T wave and QRS wave. Both atrioventricular valves are open. Both semilunar valves are closed. Why is blood flowing into the heart? What's causing the blood to flow into the heart? Pressure. All right, so we're going to be emphasizing the presence of a pressure gradient. In other words, a higher pressure in the inferior vena cava than in the atria is pushing blood from the inferior vena cava into the atria. All right, a higher blood pressure in the pulmonary veins is pushing blood from the pulmonary veins into the left atrium. Then we have our SA node firing. The SA node fires, our electrical current passes via gap junctions from atrial muscle cell to atrial muscle cell. We see atrial contraction as the AV valves remain open. As the atria start to relax, now the ventricles will contract. Semilunar valves are closed during all this time because pressure is higher in the aorta than in the pulmonary trunk. As pressure increases due to contraction, that pressure, being greater than atrial pressure, slams the AV valves closed. Now pressure spikes because the ventricles are continuing to contract, but there's no place for the blood to go. So pressure rises very high and very rapidly until it is greater than the aorta and the pulmonary trunk. And that pressure being greater is going to push the blood through and open the semilunar valves. And we reach ventricular ejection. Then the ventricles relax. Pressure in the ventricles starts to fall. As it falls, it eventually becomes less than pressure in the aorta and the pulmonary trunk, and that higher pressure closes the semilunar valves. Pressure continues to fall as the ventricles continue to relax. Blood is always still flowing into the atria, and now the atrial pressure is greater than ventricular pressure, and we're back to the AV valves being open. Again, that is cardiac cycle. Okay? You have a diagram in your lecture notes that is on page what? 48. It looks scary. All the information on here is from there, plus a little bit more. Anytime I ask you a question about when the AV valves open, which of these pressure relationships occur, you will have this diagram. Okay? So on lecture exams, you will see this diagram. When I ask questions about it, you will see this diagram as part of the fill-in. So I might ask you to, it won't have any letters, it won't have any words on it, okay? So you need to recognize that this is aortic pressure, and this is atrial pressure, and this is ventricular pressure. And this is ventricular volume. I might say name the pressure at number 1. I might say identify what's happening here, what valve is affected, is it opening or closing? All of that you can figure out. You can look at that diagram and figure out from the diagram. For instance, I told you that this was aortic pressure. It's going to fall to an average of about 80 and rise to an average of about 120 to 125. Nowadays, that's considered to be pre-hypertensive. Okay, but back when I was in college, that was just average blood pressure. This is ventricular pressure. Notice it's rising. When ventricular pressure is greater than aortic pressure, what valve do we affect? Semilunar or atrioventricular? Semilunar. Are we going to open it or close it? We're going to open it. Now, ventricular pressure is greater than aortic. We're pushing blood into the aorta because ventricular side is greater. You can get all of that by looking at this picture. You don't have to memorize those steps. You can see that. Okay? All you have to do is read the graph. So while it looks complicated and scary, everything you need to know is there. All right? This will be on your exam. I hated to come to work today because I finished grading your exams last night.
We hated looking at this one.
And once again, maybe it's a self-fulfilling prophecy. Remember I told you that there would be charts of the 2 in, the in, the 2 parentheses 2 in, and that half of you would miss at least half the questions. So please study and don't be that person. And I said that there would be questions on this develops from what, or this structure is equivalent or homologous to what. And there would be estrogen, progesterone, and LH and FSH stuff on there. I almost cried last night. I looked at this stuff and it's like they didn't believe me.
We do now.
This will be on your heart test, okay? So put stars all over it. Study it. You will have that on your exam, both in multiple choice question forms and in the fill-in. Okay. So, as we look at the events, this is actually cardiac output, but as we look at the events of the cycle, I'm going to go to a website in just a moment, but what I want to do first is to go back to that chart. I know I have it here. And go through this with you on the board and then again on the video, on the online site. Okay? Notice, up here is the ECG. It's kind of been stretched out so that we have room to put these events. Again, there is nothing new on this chart. Okay? We've talked about every single thing that I'm going to say, except for maybe the word dichotic notch. But everything else is on there. So we can start anywhere as far as which pressures. You notice here, we look up at the ECG, the heart is at rest. Okay? So both the atria and the ventricles are relaxed. Obviously, as we already said, the autorhythmic cells are going to undergo depolarization. While the heart is at rest, what's happening to the blood in the aorta? The blood was pumped in, not the atria, aorta. Blood is pumped into the aorta. Does it just stay there? No, the pressure is pushing it, it's moving away from the heart. So aortic pressure is going to be dropping from that first moment of ejection of blood entering the aorta. As that blood moves away, it's going to be dropping until the next pressure. Does that make sense? Okay, so we see this dropping aortic pressure. And the reason it's dropping is because the blood is flowing, carrying that pressure farther along to the heart. Okay? In the atria, pressure is rising slightly, but not very much. Why isn't pressure rising in the atria? Where's the blood going when it enters the atria? It's going right through the AV valves and into the ventricles. Okay, so we don't see a sharp rise. There's a slight rise, but we don't see a sharp rise in atrial pressure. Ventricular pressure. When the heart is at rest, is ventricular pressure going to be lower than or higher than atrial pressure?
Lower.
Has to be lower or blood's not going to flow into the ventricles. Okay? So ventricular pressure is going to be lower, but it's going to mirror atrial pressure because as that increases, so is ventricular pressure going to increase? And we'll come back to ventricular volume. I want to give you guys too much. SA node fires. In response, the atria depolarize and the P wave occurs. Okay. As a result of the P wave depolarization, the atria will contract. When they contract, we see a blip in atrial pressure. That's what you see here, okay, because of the atria contraction. Ventricles follow along as the blood is from the atria is getting squeezed into the ventricles. And then shortly after the P wave, we see our QRS wave. And that, as a result of ventricular depolarization, the ventricle contracts. And what happens to ventricular pressure? It goes up. When it goes up, it becomes greater than aortic pressure. So, when the heart is at rest, before we got to this point, what we call ventricular filling, the AV valves are open, okay, or they are opened, they continue to be opened. Semilunar valves are closed. Atrial pressure is greater than ventricular pressure. That's what's keeping the AV valves open. Okay? The semilunar valves are closed. And the reason they're closed is because aortic pressure is greater than ventricular pressure. Does that make sense? Don't memorize that. All you have to do is look on the graph. Again, I want you to understand it. So remember I said atrial pressure is greater than ventricular pressure. Greater than ventricular pressure. Okay? Because of that, the AV valves are open. Aortic pressure is greater than ventricular pressure. Because of that, the semilunar valves are filled with blood and closed. So you can see that relationship on the graph. Then the atria contract, the ventricles contract, pressure rises. As soon as ventricular pressure is greater than atrial pressure, AV valves close. All right? So ventricular pressure is greater than atrial pressure. Aortic pressure hasn't gotten less, and ventricular pressure isn't quite high enough yet. So aortic pressure is still greater than ventricular pressure. So now our AV valves have closed. valves are closed. So with both the semilunar and the AV valves closed, is there any blood coming into the heart or leaving the heart? Can't, because all the valves are closed. So this period, from the time the AV valves close until the semilunar valves open, is very narrow period of time, but it's called the isovolumetric. The ventricles are contracting, so it's called isovolumetric contraction. The ventricles are contracting, but there's no change in blood volume. So that's going to start right here. As soon as the AV valves close, so here's where the AV valves close. As soon as that pressure relationship switches, semilunar valves are still closed. Aortic pressure rises rapidly, and it becomes greater than the pressure in the aorta. Now the pulmonary trunk will be the same thing, but we're only going to talk about the aorta here. So as soon as the ventricular pressure is greater than aortic pressure, what's going to happen? It's going to push the semilunar valves open. So at this point, semilunar valves will open. Between those two periods of time, when the AV valves close and before the semilunar valves open, that's known as isovolumetric contraction. Down here, if you look at the bottom of your diagram, isovolumetric contraction is shown by this flat line. Volume is neither increasing nor decreasing. Okay? And with isovolumetric contraction, the volume of blood in the chambers is the highest. We'll learn that term when we do blood pressure. Okay? In diastolic volume, the end of the heart being at rest. Now the semilunar valves are open. Our relationship has changed. So our AV valves are going to stay the same. They're going to stay closed, but our semilunar valves are going to be open. Okay? I put the wrong thing up here. So this is referring to this. Okay. With isovolumetric contraction, AV valves are closed, semilunar valves are closed as ventricular pressure. As the ventricular atrial pressure is greater than ventricular. So now we flip it. Ventricular pressure is greater than aortic pressure. And let me put that second. And aortic pressure is still greater than atrial. Get myself clear right here. Ventricular is greater than atrial. So when ventricular pressure is greater than atrial, our AV valves are closed. However, when ventricular pressure is greater than aortic, our semilunar valves are open. And now blood can leave the ventricles. In this period of time, so what we're seeing now is blood leaving the ventricles. That's because of the ventricular contraction, blood's going into the aorta, so aortic pressure is leaving, is getting greater too. So we call this period of time ventricular ejection. All right? So we went from ventricular filling to isovolumetric contraction. We open the semilunar valve, blood flows into the aorta, and we have ventricular ejection.
And that's, it's considered the ventricular ejection the whole time the valve's open?
The whole time the semilunar valves are open. Okay, because blood is leaving the left ventricle and going to the aorta at the same time it's leaving the right ventricle and going into the pulmonary trunk. All right. Then we get to our T wave. And what's happening in the ventricles because of the T wave? T wave is repolarization. So the ventricles are now going to start to relax. Okay? So the ventricles relax.